Warning: hydrogen is a flammable gas. Sodium bisulfate is corrosive, wear gloves when handling it. Additionally, safety alarms are very loud by design. Wear hearing protection when performing this experiment. Greetings fellow nerds. Detectors for carbon monoxide as well as natural gas like this one have become increasingly popular to warn against such gases. They're manufactured on such a large and competitive scale that the free market has made them very inexpensive. You can even get combination units like this one that can sense both carbon monoxide and natural gas. Some high-end models will even give you readouts to give you a rough indication of the concentration. Although you should not rely on the readout for accuracy since they are not calibrated to laboratory standards. Anyway, both of these sensors will detect their respective gases, but a lesser advertised feature is that they are both sensitive to hydrogen gas. So let's demonstrate that. First, I'm going to make a very crude hydrogen generator by getting an acid solution of sodium bisulfate. I used about 10 grams in 90 milliliters of water, but the exact amount is not critical. Then I dropped in a piece of zinc metal which will react with the acid and generate hydrogen gas. You can use aluminum metal, but I prefer zinc since I find the hydrogen evolution slower and more steady. Now all we do is place the detector over the hydrogen source and wait. It takes some time for the gas to diffuse into the sensor, so be patient. I fast forwarded a good minute until I had a reaction. And there we go, the reading changed. The detector thinks it's detecting carbon monoxide and is giving a reading, but it's actually reacting to hydrogen. Yeah, there we go, the alarm has been set off. Interestingly enough, the long beep and even the display indicates it was the natural gas sensor that was tripped, not the carbon monoxide sensor. Both sensors were activated, but the circuitry considers the natural gas sensor as taking priority. Let me take it away from the gas so it resets, and I'm going to try again. I'm trying to orient the detector so the hydrogen just saturates the carbon monoxide detector. Yeah, still detecting gas. Oh, there we go. The carbon monoxide sensor is now generating such a strong signal that the circuitry now considers that the higher priority signal and raises the 4 beep alarm sound. You can see the display for carbon monoxide is off the scale. Now at this point you might be asking, why do these sensors even have the ability to detect hydrogen, and why isn't that listed anywhere? Well, the ability to detect hydrogen isn't a design feature. It's just a side effect of how the sensors work. Let me open up my detector to show you what's inside. Now I don't know enough about electronics to tell you how the circuit works, but I can tell you this large cylinder that looks like a battery is actually the sensor for carbon monoxide. It works by oxidizing carbon monoxide along with the moisture in the sensor at the anode of an electrochemical cell. The protons generated dissolve and move through the electrolyte to the cathode where they close the circuit and pass a current. The current generated is measured and correlates to the carbon monoxide concentration. But if you add in hydrogen gas, it can also be oxidized and will also generate protons and pass a current just like carbon monoxide, giving you a false positive reading. The sensor is still much more selective and sensitive to carbon monoxide though. Hydrogen has a much weaker response, so the true value is much greater than what you're seeing here. You could read 50 parts per million of carbon monoxide, but actually have 1,000 parts per million of hydrogen in the air. Now this tiny easy to miss component here is the combustible gas sensor, and can sense things like propane, methane, natural gas, and so on. It works by heating a semiconductor element of tin oxide. This saturates with oxygen from the air and in turn increases the resistance of the tin oxide. When it comes into contact with reducing gas like propane, the high temperature element essentially burns the gas with the oxygen inside the tin oxide and depletes it of oxygen. The loss of oxygen from the tin oxide makes it conductive and lowers the resistance. The change in current flow can be used to determine the gas concentration. So it's essentially a destruction of oxygen sensor rather than a combustible gas sensor. Although when you really think about it, most gases that destroy oxygen from a sensor are combustible, so the label is still accurate. Hydrogen is also combustible, so it does the same thing as natural gas and reacts with oxygen in the sensor, depleting it, giving a positive reading. The sensor is doing exactly what it's intended to do. detect a combustible oxygen-destroying gas. Now you might be wondering if this sensor can be used to detect low oxygen concentrations, vacuums, or oxygen-free environments since it relies on lack of oxygen in the sensor. It cannot reliably be used that way because you still need to destroy the oxygen already absorbed in the sensor. So it truly is a destruction of oxygen sensor rather than a lack of oxygen sensor. As a side note, this large round object here is a piezoelectric alarm. It's not in itself a sensor, although I see a lot of websites that inaccurately mislabel it as such. So now that we know our carbon monoxide sensors can detect hydrogen, what can we do with this knowledge? Well, it's a feature or a flaw depending on your application. If you're working with hydrogen gas, like an analytical lab that uses hydrogen carrier gas for their gas chromatograph, a carbon monoxide detector can be a nice cheap leak detector. In this case, it would be a useful feature. But in some cases, hydrogen interference can be a bad thing. Like if you're in an industry that uses both gases, then not being able to tell the difference when the alarm goes off can severely hamper your efforts in finding and stopping the true cause. Better sensors that are specific to carbon monoxide or hydrogen do exist, but they are expensive and not cost-effective for domestic applications. Especially since one of them, hydrogen, is very rarely encountered in dangerous concentrations. Nonetheless, for you amateur chemists that want a cheap hydrogen detector, now you have one. Before I go, I should mention something about lifespan. Electrochemical sensors have limited lifespans as their elements break down. As this happens, the response to actual carbon monoxide will decrease and eventually stop entirely, giving you a false zero reading even though there is carbon monoxide or hydrogen everywhere. So they continually need to be replaced every few years according to the manufacturer's instructions. Anyway, thanks for watching. Special thank you to all of my supporters on Patreon for making these science videos possible with their donations and their direction. If you're not currently a patron but would like to support the continued production of science videos like this one, then check out my Patreon page here or in the video description. I really appreciate any and all support.